Hello, everybody, and welcome back to another video. Today, I wanted to do a little hands-on about building and evaluating a linear regression model. Last time, we talked about supervised learning machines and the two tasks of supervised learning that are regression and classification. And one of the most well-known or used supervised learning model is a linear regression model, where we're trying to build a linear relationship between the target variable, in this case, that is going to be continuous variable, and the explanatory variable. And the goal is just to kind of build a linear functions that will match up all those explanatory variable with the target variable. That way, we are able to predict maybe future car prices or house prices based on the function that you're building from the linear regression model. So how do we do it in Python? This is going to be the topic of today's, and we're going to be using our cars data set that we've been using for a long time. And yeah, and the data set has already been cleaned, preprocessors, the feature engineering step has already been done from past videos. So we're just going to be using that last post-process data set to build our model. So we need to do all of those steps before building our model. This is um not negotiable. So we have our cars data set. We need to import the necessary libraries, the pandas for data sets, and sklearn is just a powerful tool to build linear models or machine learning models in general in Python. And we're going to be making a good use of the sklearn libraries and all of those functions that comes with it, like for linear regression and train test split to split our data into training and test. And how to evaluate our model, we are going to be importing those metric, the mean squared error and the mean absolute error. If you don't know what that means, it's right um, under last course from us. So just go back and kind of read what those things mean. And let's just run this and let's have like a look at usually what our data sets look like after pre-processing data. And we have this, we have for each car, we have the year, the engine type, the engine cylinder, the transmission type. If it's automatic, the transmission. If it's direct drive, the transmission. If it's automated, manual. And the target that we are focusing on, the MSRP, which is the manufacturer retail price for a car. The goal is just to use all of those one, two, three, four, five, six, seven variable to explain and build a linear relationship that will predict the MSRP. This is exactly what we're doing here. We have the data set right here. And let's now just split our data set into X and Y. X is representing the variable we're using, and Y is representing the target variable. So this is X, this is Y, and the next step would be to split our data set into training and test because we are going to be um, building our model on the training data set. So the model is going to learn so much on the training data set, but we want a model that is able to generalize and able to predict very well the car price on new data set. And this is why, and this is how the test data set is it's very important here. We are just going to be doing that with training, test pay, and giving 20% of our data into the test sets. And now we're good to build our model and fit the training data into the model by using this linear regression and feeds. And once we have that, the model has been built, the model has been trained on the training data sets, and we can now just predict what would be the outputs. Maybe we want to just predict and just evaluate how the model will perform. We get the predictive variable of all of the data from the test sets. And once we have that, we can then just evaluate our model by saying, oh, okay, so the model has predicted what would be the car price of any car features from the test data set. But we've already know the actual car price from those car features based on what we have from the test data set. So to evaluate the performance of the model, we kind of just know how far are our prediction from the actual um, test data prices. And we want to make sure we're doing it on the test data just because on the training data, the model is always going to perform very well. You know what I mean? Because the model learns so much from the training data set that every time it's going to do so well. But we want to evaluate or to assess the capacity of this model to also do very well on data set it has not seen before. This is why we pay a close attention to the test data set. And then we do that by just um, viewing just recording what would be the mean absolute error and the mean squared error, and those are those error. So the mean absolute error is 22,000 and the root mean squared error is 42,000. Considering that it's car price data set and the car prices are usually higher, like 40,000, 100,000, so this is really not a bad metric. And we can just now predict, like, kind of output what were the actual price and what were the predicted price, and just see how it looks like right here. And those are the actual prices from every car data from a test set, and this is what our model predicted. It's not perfect, but as long as it's kind of a bit closer to what we are looking for, it's not bad. But we can see that for some of the car data, it's not really doing a good prediction like right here. So one thing we can do is, oh, how can we actually kind of find a way to improve the performance of the model. We can go back to the features we use from the data set. Maybe we can go back to how we build the model, or if we need to add more parameters. But let's just work on improving the performance of a model by adding more features into the data. And let's now add the features like the highway MPG and the popularity. And honestly, the highway MPG, it's something that should be very important because it's like the mileage of the car, and should be something that we consider when we are just trying to predict car price. So we're adding these two features, and then we run the same thing for the model and everything, and we build the model, we predict the car prices from the test data sets, and we kind of find what would be the metric values in this case. And we have for mean absolute 21,000 and for mean squared, root mean squared 42,000. And we had 22,000 and 43,000. So we've actually improved the model by reducing the metric error. And if that's the case, then we can just take this new model. And since we've improved the model, we now use this second model for our predictions. And let's view how actual versus predicted looks like, much better than how we had in the past. But last but not least, the goal of creating a model is to do feature prediction. So you might be working with a stakeholder that asks you to build a model, and then after that, you kind of just want to use your model to do something else. And your stakeholder will be asking you, maybe predict the car price of a car that will be built, or where the year is 2026, the engine HP 200, the engine cylinder is 4, the highway is 30, the popularity is 1500, and the transmission type is automatic. And this is a new cars data that comes into the equation, and we want to predict what will be the car price for a car that has all these features. We record the car price we record the car price features as a user data, and we use our build model to predict the price. There we go. So the price predictor issue is going to be $13,000. What if now we change the highway to like 300? Um, $319,000. Why did we change to 50? $36,000, because this highway MPG is evaluating the capacity of your car to run smoothly on a long distance. So the higher the highway, the higher the price of the car. And this is actually really showing that our model is actually doing a pretty good price. A pretty good job as using those features and building a model that is reliable and consistent and is also reflecting what we see in real world. This is exactly what a machine learning model is about, kind of just using the data to predict the features, to predict the future outcomes, and using those future outcomes to make business decisions. And this is exactly what we've done here with this model. And, I hope to see you in the next video. I hope it was a bit informative. It was kind of very short, but hope you guys have actually learned something from it. And yeah, it's everything for today. Let me know if you have any questions, just reach out to me. And thank you very much for watching. And yeah. Thank you, and have a good day.